Hi everyone. Today we're going to study multiplication of matrices. Multiplication can only be performed if the number of columns of the first matrix equals the number of rows of the second matrix. Then the process is carried out by doing row by column multiplication. Let matrix A equals the element A sub ij, and this is with subscript m by n, be an m by n matrix, and capital B equals matrix with element small b with subscript jk, and this is with another subscript n by p, be an n by p matrix. Then the product of the matrices A and B is the matrix capital C of order M by P. To illustrate, suppose we have here two matrices. Matrix A with dimension M by N. Matrix B with dimension N by P. Note here that the column of N is equal to the row of B. For the product AB, the size of this product will be M by P. The M comes from matrix A and the P comes from matrix B. Example, if matrix A equals 1, -3, 0, 2 respectively, and matrix B equals 1, 0, -2, -1, 2, 3 respectively. Then find the product AB. First, let us note that matrix A is a 2 by 2 matrix and matrix B is a 2 by 3 matrix. We can see that the column of A is equal to the row of B. Therefore, AB is defined. Then later, AB is a 2 by 3 matrix. The 2 here is the number of rows that comes from the row of A, and the 3 here is the number of columns that comes from the number of columns of matrix B. Then we will do row-column multiplication. It becomes like this. We're going to use the rows of A to be multiplied by the columns of B respectively. For the first element here, we will multiply the first row of A by the first column of B. For the element here, the row 1 of A multiplied by column 2 of B. Row 1 of A multiplied by column 3 of B. Row 2 of A multiplied by column 1 of B. Row 2 of A multiplied by column 2 of B. Row 2 of A times column 3 of B, respectively. Applying this, we will have the following numbers. For the first element, we will have 1 times 1 plus -3 times -1. Second element here will be 1 times 0 plus -3 times 2. Third element, 1 times -2 plus -3 times 3. Fourth element, 0 times 1 plus 2 times -1. Next, 0 times 0 plus 2 times 2. Then 0 times negative 2 plus 2 times 3. And from here, we will simplify the numbers. The first element becomes 4. The second element here is negative 6. The third element is negative 11. This element is now negative 2. The element becomes 4. And the last element here is positive 6. Note that the product AB is a 2 by 3 matrix. This is the final answer. Let capital A, capital B, and capital C be matrices whose sizes are multiplicatively compatible, and K is a scalar. First property, the product AB is not equal to the product BA. We say that matrix multiplication is not commutative. Second property, the product of AB times matrix C is equal to matrix A times the product of BC. Now, matrix multiplication is associative. Third property, A times the sum matrices B plus C is equal to the product AB plus the product AC. Property number 4, sum A plus B multiplied by matrix C is equal to product AC plus product BC. 5. The scalar K multiplied by the product AB is equal to the product KA multiplied by B. And this also equal to the matrix A times the product KB. These are the properties of multiplication of matrices. I hope you learned something from this video. See you again next time.